All right, this is the warm-up. So the first one says to measure AB to the nearest eighth of an inch. So if you look at AB, right, it goes obviously your full 1 inch, and then it's 1, 2, 3 past that. So this would be 1 3/8 inch.
Well, you have to put CE equals, AB equals.
Nah, it doesn't matter. That wouldn't matter. All right, to CE, you're adding, right? This would be the segment addition postulate. If it asks you to justify it, you just have to add the 7 and the 15. So CE is 22. 3, plot points, -3, 5, 1, 2, 3, 4, 5. This is F. G, 2, 5. H, 3, 1. And J, 3, -3. And then it says R, F, G, and H, J congruent. So you're finding the length of FG, which was how long? 5, good. And then HJ, which was? 4. So are these congruent? No. Not the same length, different lengths, anything like that. Size, length, okay, any of that. That would be the description of why.
When I asked to explain, maybe I have to go that in depth.
I mean, what else did you put? What was long? What was shorter than 2 words?
No, HJ would be congruent if it were one more down.
If it were 1 more down. So like if it was 5 in length,
yeah,
I would say it would be a better description.
Yeah.
And I like that you said that I went too in depth when you have 700 words on your slide. All right, 4 says find KL. So, all right, so 4 minus a -3, which is 7. Or you could have done -3 minus 4, but you had to put it in absolute value. Or you could have counted. Either way, answer 7. So you have to either use the word line with the 2 letters or you need the arrows over it. 6, name the plane that contains them. That would be plane T. 12, I'm going to work my way down. 8, plane RST is just an example. So it had to be any 3 non-collinear points. Okay, pretty much anything involving T would have made it non-collinear. So RQT, QST, any of those would have been a good name. Has to be non-collinear. Couldn't be RQS. Number 10, name a point that's not coplanar, and that's W. Back up to the diagram on the top. 12, what's another name for AC? It would be CA. You had to keep it a segment, so you couldn't change it to a line. If you didn't put the line over it, that's okay too. Just CA by itself is also another name for it. 14, all the rays with the endpoint E, and the arrows were important, right? The endpoint goes over E, and the arrow goes over the other letter. So E, B, E, C, E, D, and EA. 16, this is just a sample because there's more than one option, but E, C, and EA are rays that are not, because they went like this, EC, oops, get the highlighter, EC and ED, those are not opposite rays. You could have done ED and EA. Those are not opposite rays. You could do EA and EB. Those are not opposite rays. And you could have done EC and EB. Those are not opposite rays. Questions on these? Okay, 26. The problem is the arrows are not on there. When you're naming a ray, you have to put the arrows. So there are going to be parts of your quiz in which it's going to ask you to give a name of things, and we're going to nitpick on stuff like that. The rays have to have 1 arrow. The lines have to have both arrows. So be really, really careful.
A segment. If it's
What's there given to them would be a segment. So if it said 2 segments, that would be, you can either do YC or you can put YC without the line over it, and it's still a segment.
Okay.
Arrows are rays, double arrows, lines. Okay, 28, name a point that's collinear to B and I, that would be C. 30, a point that's not collinear. A is a sample answer, but literally any other letter except for I would work there.
So D?
D is fine. It just couldn't be, any other letter except for C. It just couldn't be on this line. So anything else would work.
Wait, what if it's F?
Fine.
No, because with B and I.
B and I are that top. It's not just B, right? It had to be B and I. That only forms one line, which is that back edge. Yeah. 32, collinear to C, G, and F would be B. C, G, and F is anything on this back. So it could have also been I. 34, the intersection of B, G, F, which is that back side, and plane H, D, G would be the right side that intersects at, and it's careful because it has to be a line, right, where they intersect. It would be line CG. Planes intersect at a line. Because remember, this is just a representative of what a plane looks like. Technically, that plane has no end. So the edges are lines. So GC is the only other way to write it. That had to be those letters. All right, the next one. So 40 wasn't too bad, right? It said what are not coplanar with P, Q, and S would be this bottom. So any other points?
I just put one. Or do you have to put all of them?
It said name all the points. So just be careful, make sure you read it, okay? Because it said all. Name all would be all the ones, basically. Wait, I highlighted the wrong one. P, Q, N is the front. So all the other ones, K, L, R, S, would be non-coplanar. Then R, K, N is this left side. So excuse me. So all 4 points on the right side are not coplanar. And then the tricky one was the Q, K, L, right? So this actually would connect to P. There's a plane there even though you don't see it. It would be as though you cut this, like if this was like a block of cheese or a block of butter and you cut it from end to end like that, that would be the plane. If you opened it up and you were looking at it, that would be the plane that it's talking about. So the ones that are not collinear are these front corner ones, N, M, and the back corner ones are S. It's probably, I mean, that's like the hardest part about geometry is trying to figure out what happens that's not already obviously there. All right, 50, so it said your friend walk opposite directions, forming opposite rays. You were originally at the corner of Apple Avenue and Cherry Court. Name the two possibilities of the road and direction you and your friend have traveled. So the only two, north and Cherry Court or south and Cherry Court, are the only ones that are in opposite directions on that side. You could have gone, they had to form a straight line, so the other one would be Apple Avenue. It doesn't work the other ones because they're not straight lines. So opposite rays form the straight lines. What was next? 56 on the right hand side. A line never has endpoints. 58, a plane and a point sometimes intersect. 60, 2 points always determine a line. 62, any 3 points not on the same line always determine a plane. So that would be 3 non-collinear points, which is one plane.
So for 60,
yeah.
Sometimes because can't there be just 2 points?
Any 2 points form a line.
There's always going to be like a line through a point and another point.
Yep. Exactly one line. So one and only one. All right, then the just absolute value practice here that obviously led into the next section. 66 was 6, 68 was 4, 70, x is negative 16, and 72, x is 42. So you'll see these brought in to like kind of practice your algebra skills as you're going through the geometry stuff. Now this is 1, 2.
I got it right.
So 1, 2 said what's different, right? Different word, same question. Which is different, and find both answers. Okay. If you had actually plugged in those values, the one that was different was that one on the top right, BC minus AC.
What does it mean by find both answers?
Which is different. I don't know what that means. That's the only answer.
Okay.
I think it means find all those answers that are there to determine which one is different.
Okay.
That's what I think it is.
Yeah, because I was confused.
I don't even know what that means.
Was incorrect.
Yeah, no. All right, 10. Oh, I'll go to that one in a second. 16 and 18. 16 is 26. 18 is 19. You just had to add those two together. And yes, there will be stuff that is like on level with that, like pretty easy mixed in with the rest of the questions. Okay?
For the test, do we have to put FH equals?
No. Just give the number. Okay, so 10, you had to find the measurements of each. One was 5 and one was 2, so they're not congruent. 12, you had to find, again, the measurements of each. This time they were both 9, so they were congruent. and 14. One was 3, one was 7, so they're not congruent. Easy stuff, right?
Wait, so all of them were not?
No, 12 was.
12 was congruent.
They're both 9.
Yep.
20 was FH is 7. 22, what are we looking at? FH would have been 13. 24, it should be different because it's not a sum, right? Wait, it should be different. Yeah, because you're finding the difference to find the length. Why is that blurry? Not the sum.
How come they put the absolute value things?
Because its absolute value is the distance, but you use absolute value to find distance, but it has to be the difference that you're absolute valuing, not the sum. Does that make sense? Like you could do 1 minus 4.5, but it has to go in absolute value.
Because it can never be a negative.
Exactly. So the order doesn't matter of which coordinate you put first if you always absolute value it. Okay, 26, you're literally just adding, right? Because this is not on here, right? 26, you just had to add those two. So 3, 8, 8, 1. 28, here's the algebra again. AC, you're writing an algebraic expression that says 8x minus 1. And
I had a problem with these.
why?
I don't know, because like on the first one I just put x plus 2 plus 7x minus 3 equals.
So there's no equals. That's the problem. So one thing was a given, and it's hard to see on the board because it's blurry. But the word expression means it doesn't have an equals. It means it's going to be something that's just combining terms. It doesn't have an equals. If you did equals, that's okay. But the word expression means it's not going to be an equation, right? So which means you can't solve it. And really all you had to do from there, Santi, was just combine your like terms. Yeah, just make it as simple as you can. And then B should have been 5y plus 20, same thing. This time you had to subtract. So you had to do the big one minus the little one. And you should have gotten 5y plus 20. Still good? Yeah, okay. All right, 36. A, C, and CD are both 6. So this is where you want to, I would say, draw all over this diagram based on what they give you. It said AB was congruent to BC. So those two are the same length. And then it said AC was the same as CD. And it says the whole thing is 12. So if I work backwards from that, if the whole thing is 12 and it's cut into 2 equal parts for AC and CD, that means this is 6 and this is 6. And then the one on the left is cut into 2 equal parts, which means this is 3 and this is 3. So that says, what's the probability that the measure of a segment is greater than 3? You'd have to give the segments that are greater than 3, and that's where you would get the other one. So the 2 that are greater than 3, the 6 and the 6, would be 2 out of the 3 total segments that they gave you. So this is a great standardized test question. Okay, yeah.
Well, wouldn't it be 1/3 because technically it's like split into 2?
No, but it's saying from those segments that were given, suppose you choose a segment at random. This is one segment, this is one segment, and this is one segment. But you could also make this a segment as well. So of those, which would be greater than 3, you would do the ones that are 6.
Okay.
Yeah.
So what would the answer be?
So it's 2/3.
2/3?
Yeah, because you do the 6 on the right, the 6 on the left. Would both be bigger than 3.
Because I don't know why I counted the 12.
Well, 12 is your overall length, not the number of segments. So you're trying to figure out how many of the segments would be greater than out of the total number of segments. So like if you went through here, like name all the segments that are possible on this. Give me all of them. A, B, B, C, C, D, A, D,
And AC.
A, C, B, D. Did we get them all? 1, 2, 3. Those were the easy ones. 4, the big one. 5, 6. We did AC. Yeah. So of these, then you would figure out the length. So this is 3. This is 3. This is 6. This is 12. This is AC would be 6. BD would be 9. This one. Well, this is the whole segment, which is why I think it's not counting. No, it is. This one and this one is 4 out of the total number of segments, which is 6,
Okay.
which makes it 2/3. So you would have to figure out all, and this, like I said, this is a great standardized test question. Like, this isn't going to show up on your quiz, but this is a great standardized test question because it pulls in geometry and probability. And standardized tests love to do that. So probability is what you want to get over the total amount of them, right? So you have to figure out what all the options are, figure out all the lengths, figure out how many of them are bigger than 3, and then put it over the total amount of them that were there. All right, 38 is 1. 30 is the square root of 34. 42 is 6, and 44 is negative 13. Again, reviewing skills that we're now going to use in 1-3. Questions?
Oh, I did.
Which one?
I had trouble on 44 because I forgot what to do when I have a fraction.
So you actually have options. Like I could have divided the 2 into each of those if they were even, but I would not the way that they are. To get rid of the 2, because we're dividing by 2, I'm going to multiply this by 2, and I'm going to multiply this by 2.
Yeah.
It's going to cancel from this side, so I end up with negative 5 plus x equals negative 18, and then I'm going to add the 5. And I get x equals negative 13. So if you're dividing by a number to get rid of it, you're going to multiply by it. It cancels from the 1 on the left, but it gets multiplied by the negative 9 on the right. Good? Yeah? Okay. All right, we're going to start them, and hopefully they'll be back in time. But the good news is there's really only 2 big ideas in this section, and that is midpoint and distance. And these are also stuff that's in algebra. So hopefully this is review, except now you're going to be applying it to geometric figures. Okay. So a midpoint, and if you think of just the parts of that word, mid would be the middle, right? And it's a point. So it is the midpoint. It is the point that divides the segment into 2 congruent segments. In this diagram, M is the midpoint of JK. And if that's the case, then JM equals MK. Or you can write it as JM is congruent to MK. So the difference between this symbol, obviously we know this one, this is equals. This symbol is our congruent symbol. And you can write it either way. No, it doesn't matter. So no matter where what is.
So let's say it's 1 on it's M, it's 1, but the other side equals 5.
No, then it's not the midpoint. So it has to be the mid. It has to, and it will show it in different ways. Like this is 3 and 3, right? So it's showing you the lengths are the same. Or you'll see congruency marks like this, and that's how else you would know it's congruent. But that has to be the middle.
Okay.
And you'll see this applied in different ways, right? So it's going to say if this is true, what segments are congruent, or it could give you that they are congruent, so then find the length of a missing segment, that kind of stuff. That's what we'll see in the examples. All right, a segment bisector is a point, ray, line, or line segment, or plane that intersects the segment at its midpoint. So if I have it has to be a segment that is being bisected, right? Otherwise, you can't find the middle. So you can't do this with a line. But AB is what's being cut in half right here at M. Anything that runs through M would be a bisector. So this is line DC. It could be segment DC. It could be ray DC. And all of those are still segment bisectors because it's literally hitting that segment at the center. It could be a plane. And as long as it's cutting through the midpoint, as long as it's passing through M, then it's still the segment bisector. If it's the segment bisector, then I know the 2 segments that it's divided into are equal. So segment bisector means it's cutting the bisector at its midpoint. All right, example 1 says, in the skateboard design, VW bisects XY at point T, and XT is 39.9. So the diagram even shows that it's bisecting by giving you these little congruency marks, okay? So the one that's cut in half is the XY. We know nothing about the length of WV. If XT is 39.9, how can I find XY? So I can add 39.9 plus 39.9 or multiply by 2. You could do it either way. That time we were given 1/2 of the whole segment, so I just double it to get the whole segment. All right, example 2 says point M is the midpoint of VW. Find the length of VM. So if M is the midpoint, and it is already marked here, these are congruent, how can I find VM? What's the first thing you have to do?
Add them at the.
I would add them if I knew the whole length, right? Like if it said VM was blank, then I can add these two and set it equal to the whole length. But I don't have any length. What can I do?
Then combine the length terms.
Well, what's true about VM and MW?
But they're the same.
They're the same. So I can actually take and set 4x minus 1 equal to 3x plus 3 and solve for x here. So this time I want an actual value. So I'm going to solve. I'm going to subtract the 3x. X minus 1 equals 3. I'm going to add the 1. And I get x equals 4. But it's not asking for x. It's asking for VM. So I'm going to do what with that 4? Plug it back in to the VM. 4 times 4 minus 1, 16 minus 1, which is 15. Would it have mattered which side I plugged it into? No. As a matter of fact, if I had extra time, I would plug it into both and make sure that they're the same. So 4 times 3 is 12 plus 3 is also 15. It's an easy way to check your work. So again, segment addition postulate from section 2 said if I took these two and I added them up, I'd equal the whole, right? So if I had a value for VM, I could have done that. If it said VM was 20, I could have added these two, set them equal to 20. But I don't have that piece of information. What I do have is that they would be the same because M is the midpoint. So I set them equal to each other, solve for X, and then plug it back in to find VM. Be careful because sometimes it will do something like instead of VM, it would say find VW. So what would you have to do there?
Combine them.
I can add them, like put the X back in if I add them and combine your like terms and add them, or I could find what?
One side and then add.
Exactly. I could find the 15 and then double it to get the WV. So just make sure you pay attention. I would say, you guys, I mean this in the nicest way possible, but you tend to get lazy and rush through instructions and you try to just do the problems how you think they're supposed to be. And in geometry, it's wordy. You have to make sure you read those instructions. All right. The second concept is the midpoint formula.
You have to remember this?
Yes. This is one of those formulas that does not go away. Like I taught pre-calc honors advanced and you use midpoint formula. It just doesn't go away. Okay, it will be in algebra 2. You'll see it in pre-calc again. The midpoint formula is if you're given coordinates. So if you're given an xy and an xy of 2 points and you want to find the midpoint between those two, it's simple. You just have to remember it. You add the 2 x's and divide by 2 and then add the 2 y's and divide by 2. And your answer is going to be a coordinate point. So it's going to have 2 parts, the x of the midpoint and the y of the midpoint. It's literally like finding the average of the x and finding the average of the y. Add them, divide by 2.
Okay, that's fine.
And you're going to get some that are fractions and you're going to get some that are whole numbers. They're going to get mixed in, okay? So example 3 says the endpoints of RS are R, which is 1, -3, and S, 4, 2. Find the coordinates of the midpoint.
So
What do I do?
So
1 plus 4
wait.
Good.
over 2,
Good.
and then plus -3 plus
No,
2
it's not plus.
It's a comma.
Oh.
You're good. It's a comma instead of a plus. You don't want to combine them into one.
Okay.
And then I'm going to keep going. So 1 plus 4 gives me 5 over 2. And -3 plus 1 gives me -1 over 2. And you can leave it just like that. You do not need to convert it into decimal form or mixed number form.
Wait, so then when we graph it,
So if you were, let's say it said to graph it, it should line up, right? 2.5, 5 over 2 would be 2.5. And then -1/2, and it should line up with what looks like the midpoint of that. Still good? This time, you're given the midpoint and an endpoint. So I know the endpoint, 1, 4, and I know the midpoint, 2, 1. What I don't know is the other endpoint. So these you're actually going to set up as though they're 2 equations, okay? And it might be confusing the first time I do it, but hopefully it makes sense. So if my equation is x1 plus x2 over 2 and y1 plus y2 over 2, and this typically equals the x of my midpoint, and this typically equals the y of my midpoint, then I can literally split them and plug in the information I have. I will have one unknown, and then I solve the equation for it. So what's the x coordinate of my midpoint?
2.
Good.
2.
It doesn't matter which one we make x1 and y and x2. So let's just say these are my ones. x1, y1. My x1 is 1. I don't know the x2. And then I'm going to plug in the information for the y. I'm going to go back and solve that, but I'm going to plug in the information for the y. So y1 is 4. I don't know y2. And the y coordinate of my midpoint is 1. Now there are two separate equations, right? Which it looks like the skill that you practiced at the end of yesterday's homework, right? The first thing you're going to do is multiply both sides by 2. I get 4 equals 1 plus x2. Subtract the 1. x2 equals 3. So that's the x coordinate of my endpoint. And then I repeat that whole process for the y. So multiply by 2, multiply by 2. These cancel. 4 plus y2 equals 2. Subtract the 4. y2 is negative 2. And if you've done it correctly and you had a graph, you could plot that point. I would go 3, negative 2 and plot my point. Had I plotted these other 2 points, it should have looked as though these were equidistant. So the first example we practiced was if you were given both endpoints, add them, divide by 2, add them, divide by 2. If you are given one endpoint and one midpoint, you have to do it this way. You're setting up 2 separate equations and you're solving for those endpoints. I think this is the most confusing of all the stuff that you're going to do. So hopefully this is not that bad. Yeah.
Is this quiz going to be hard?
I think your quiz is super easy if you know what you're doing.
Like cake?
Like you have to know the difference between your vocab terms at the beginning, the lines, the segments, the rays, and all that stuff so that the arrows and that stuff don't get you. But the rest of it is super easy. All right, last part is the distance formula, and you have to know how to simplify square roots, which is what this is, okay? So the distance formula gives me the length of a segment or the distance between 2 points, okay? This is also a formula you have to know and never goes away, okay? And it is the square root, so the distance between 2 points is the square root of x2 minus x1 squared plus y2 minus y1 squared. You did do this in algebra, yeah. So if you had 2 coordinate points, you would plug them in. And it doesn't matter which ones you make the 2s and which ones you make the 1s as long as you're consistent. What's going to happen here is you'll end up with a square root. And sometimes it's a perfect square, like square root 25. And you'll give me that answer as 5. And sometimes it's the square root of something like 17. And you'll give me that answer as the square root 17. So you will always keep these exact. And then sometimes you'll get square roots that can be simplified. So if I had square root 20... this is where it gets trickier, right? You have to break this down into its factor tree. Wait for it. I promise you I did not write that slow. Thank you. I'm going to break this down into its factor tree. So this would be 2 and 10 and 2 and 5. And the rule is that it's a square root. Square means 2. You need 2 of that number to bring it to the outside of your square root. So because there's 2 2s, 1 2 goes to the outside and the 5 stays underneath. I'm going to do one more because we're going to practice it again. Okay, so square root, let's say I say 32. How does that break down? And it could go any way you want.
8 and 4?
8 and 4. And I could break 4 down, or I could bring the 2 right away. But I could break 4 down. I could break the 8 down until it's a product of primes, right? So you want to get till it's all the way to the primes.
So 16 and 2?
So this brings out 2. Good. This brings out 2. This one stays underneath. 4 root 2.
Is there going to be like hard algebra?
What do you mean by hard algebra?
Like factor?
Yes.
Like in geometry?
Not for a while, but yeah. It happens probably. All right, let's do these and then we're done. Okay, find the distance between the 2 points. And again, it doesn't matter which ones we make x1, y1, x2, y2, as long as the numbers match within the parentheses. So I'm going to do the square root of 7 minus 13 squared plus 10 minus 2 squared. What's 7 minus 13? Good. Negative 6 squared plus, what's 10 minus 2? 8. What's negative 6 squared?
37.
Good. And 8 squared?
64.
Good. 36 plus 64. 100. Is 100 a perfect square?
20.
Good. Oh, 10. And if you forget, like if you're unsure, just break it down to its factor tree. You would have had 2 2s and 2 5s, and that's how you would have known it's 10.
I feel like the factor tree takes a long time.
Well, because there's going to be some that you just know, which are easy. But you get a number like, I don't know, 240, you're going to have to break it down.
Yeah. Or it has to do something with 12.
It does have something to do with 12, yeah. I start with 2s if they're evens because you're going to eventually get to the prime anyway. So I always start with 2s or 3s, right? 5 sometimes, but you're going to always want to get to a prime. So I just divide 2 into it. Just keep cutting it in half until you can't do it anymore. All right, last one. Four minus 2 squared plus negative 1 minus 3 squared. I'd get the square root of 2 squared plus negative 4 squared. 4 plus 16, which is square root 20. We just did this one, right? This would have been 2 and 10, 2 and 5. 2 2s go to the outside, and the 5 stays underneath. So be careful when you're doing these for homework. There should never be a decimal in these, okay? You want to make them simplified radicals. And that's how they would be left on your quiz as well. That's it. Not bad, right? Okay.
No.
So I'll publish the assignment. You guys can actually, you have 10 minutes or 8 minutes if you want to get a head start.
For homework?
Yeah.
Okay, yeah.
And then tomorrow we'll do the warm-up. We'll review a little bit. And then the next day is your quiz on 1-1 to 1-3. So all the